And now here is the test that we had. As you can see, these are the basic C programs, and what I want us to do is to answer some of these questions and also write some programs to maybe accompany some of what we'll talk about, and also to show us what we're required to do when it comes to answering such questions, because some require us to do code, some require us to write pseudocode, some require us to just explain things. And as we start with the first question, we can see that the table below shows the grading criteria that is used at ABC College for awarding students diploma for marks in various units. What you're required to do is use this table and answer the questions that follow. And the first thing that we are asked to do is to design a pseudocode that can be used to grade and print a student marks followed by this criteria. So the first thing to ask ourselves, what is a pseudocode? So let me just open my IDE so that we can now start answering some of these questions. And let me just close the project. This is one of the projects that we have done, and what I'll do is just create a new project and say it's a command line, and cut revision. I can call it cut revision tests, and I'll just create it, and now open my main file. And now here is where we are going to look at our main program. So let me just delete all the code first so that we can just talk about these things. And the first thing is to design a pseudocode. So the first thing is to understand what a pseudocode is. So I'll just do this. These are what we call the multi-line comments, and they can be used to comment multiple lines, because that is something that you can also be used. So be asked, I mean. So types of comments, we have the ones that I've used here are what we call the multi-line comments. And for multi-line comments, these can be used to comment code or write comments in multiple lines. And inline, the other one is what we call the inline comments, and these are represented by the double slash. Okay, it uses the double forward slash, and this comment just on a single line. That is what I wanted you to understand about the inline and the multi-line comment. As you can see here, I have used a multi-line comment, and as you can see, it uses the forward slash star, and then to close you say star forward slash. That is how you can use a multi-line comment, and it's conflicting with the one that I have here. So just know that it uses the opening, the one that I've used here, and a closing one, the one at the end. And this is where we are going to be writing what we are going to discuss. And the first thing is to design a pseudocode. So pseudocode. So what to define a pseudocode? Pseudocode is not a real code. It does not represent the real code. What does it represent? Presents the instructions or flow of a program written in for example, English, that can be translated to an actual program in any programming language. So what we know by a pseudocode is that a pseudocode is language independent, such that if I write a pseudocode for maybe adding two numbers, if I give someone just the pseudocode to implement that pseudocode, they can implement it in any programming language, So if I was to design a pseudocode, so let me give an example of a pseudocode to add two numbers. Okay, this is something that we have done, adding two numbers. So the first thing you do is get first number input. So this is the first instruction of our pseudocode. The second thing that you do is get second number input. That is the second step of our pseudocode. Then the third step is add both numbers and store them in total. Okay, so this is the third step. You add them and store in a variable called total. And then the last step is display the total. So this is an example of a pseudocode to add two numbers. So pseudocode is just English-like statements. Pseudocode does not represent the real code. Instructions or flow of a program written in maybe a language like English that can be translated to an actual program in any programming language. So if I gave someone to implement these in Java, they can actually implement it in Java. If it was in JavaScript, they can actually do that. If it was in Python, they can do that, because what you are saying is you are saying that it's actually language independent. That is what we mean by a pseudocode. And now what we need to do is to design a pseudocode that can be used to grade and print out students' marks following criteria. So the criteria is the one that has been given at the top here with this table. And what you're required to do is just to design a pseudocode. So think of this. This is what a pseudocode represents. And what you're going to do now, we is to now design the pseudocode to grade and print the students' marks, to grade and print the students' marks based on the criteria that is provided. So what we need to do is now to design this pseudocode. So the first thing that we need to do is we have the marks. Okay, so you can say the first thing that you can do, okay, this is actually independent, because when writing programs, it's not a must you write the same way, all of you. Okay, it's actually, when writing programs, it's actually very flexible, because there are so many ways to just write something or implement something, but some things will remain, such as how you have to use this grading system. Something like that you have been given and you can't actually change that. But how you can implement this program is it can be different for some bits of the code. So maybe our pseudocode, we can say that the first thing that we need to do is to get the student's marks. Okay, get or scan the student's mark. Okay, so that is the first thing that we need to do. After doing that, what do we need to do next? And for a pseudocode, it's good to start with something like, you say start. Okay, here you can also say start. So you start and then get the or scan the student mark. And after scanning the student mark, what you need to do next is now to determine whether the mark is in this range, or you can, so this is optional, you can determine or ensure the mark is in the given range, which is the lowest is 0 to 100. So you can ensure it's in the given range 0 to 100, but this is optional. It's not a must. You ensure that. Okay, that can be optional. After you ensure that is in the given range, and after doing that, now here is where we award the student. Okay, award the student. So you now test for if the mark that has been input is between 70 to 100, you give a first class with distinction. 60 to 69 first class, 40 to 49 pass, 0 to 39 you give a fail. So here is where you can now do that, and you can use you can say if the mark, so you can say something like if mark is greater than 70, if mark is greater than or equals to 70, and it's less than 100. Okay, if it's greater than equal to 70 or less than 100, you can say and mark less than or equals to 100. You can say here it's not a must you use these symbols. You can also write it as this. So you can say if mark is greater than or equal to 70 and less than or equal to 100, award first class with distinction. Distinction. So you can write it as this, or you can also just write it using this basic if statement, because these ones are standard for almost all languages. Like this is how the computer makes decisions, and you do that for the others. So you say if the mark is greater than or equals to 60 and the mark is less than or equal to 69, you say award first class. You say here award first class. Then you go to the next one. If mark is greater than or equals to 50, this one is 50, and greater than or equals to 50, and mark is less than or equal to, I think it's 59. Yeah, you say award distinction. Is it distinction? Yeah. Then 40 to 49. So you say if mark is greater than or equal to 40 and mark is less than or equal to 49, you say you award pass. I think it's pass. Yeah. So you award pass. And lastly, if mark is greater than or equals to 0 and mark is less than or equal to 39, you award fail. So that is what you can do. So you can write it in full like this, or you can also do it like this. And also we tested out to see that it's not a must you provide this second condition. So you can actually say if the mark is greater than 70. If the mark is greater than 60, it's not a must you provide this second condition. It's just there to ensure that the ranges are strictly followed. So it's not a must you provide. So you can just write here, this is the same as saying if mark is greater than or equals to 70. If you test out this in a program, you'll see that it works, and I think we'll do that because we have been told to actually implement the code. So if mark is greater than or equal to 60, then here is also the same as you say if mark is greater than or equals to 50, if mark is greater than or equal to 40, and now here is where you use the else if. So you can say you will use the else if, because we said the else if is when we are testing for multiple conditions. So you can say, oh, these are else if, because we said else if is when we are testing for multiple conditions. Okay, yeah, that is what you need to know. So you can say if mark is greater than or equals to 0. So it will go from 0 to 39, because 39 is just here. Yeah, so this is how you can actually do it. And after that, I don't think there's anything that we are doing. Yeah. So the major thing of the pseudocode was here. So it just needs you to understand that in this case you have to use the else if statement. And if you are writing it in words too, you could have gone to the second one and said else if mark is greater than or equal to 60, then blah 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 blah, continue with that. This is what it was majorly testing you on. Okay, so these are just alternatives. So instead of just writing all this, you can write if mark is greater than or equal to 60. If you also don't want to write all this, you can say else if mark is greater or equal to 50. The same case to 40, the same case to 0, and I haven't introduced. Then the second one is draw a flowchart. So a flowchart, I think we won't draw it here. I think we can draw it in class because I hadn't prepared, and we've just discussed this with the class rep as the last thing. So if I had drawn it, I could have just shared, or we could draw it together. So we will just draw it together in class, because I want us to look at how we can write now these programs, and how we can how we can translate all this into a working program, and also look at what was there for the other cut. So for the flowchart, we'll draw it in class as we explain everything. Then we translate the above pseudocode now into a C program. So you can see that this is our pseudocode. What you need to do now is to translate this into a working C program. So what is our working C program? We start with hash include, the same thing that we always do, stdio.h, and then you say int main, then you return 0, and now here is where you write your program. So if I wanted to just say hello world, I could have just said printf hello world, and just do that, and we say it's good to have a new line after every printf. And yeah, let's see whether that will run. And if I run my hello world, you can see that the output here is hello world. And if I change this to welcome to programming class, welcome to programming class, and if I change that to welcome to programming class, you can see saying welcome to programming class. So what was the first thing that we now needed to do to implement our pseudocode? So here I will use a inline comment. So implement our pseudocode, and the first thing that we did was do what? We start, okay, then get or scan the student marks. So we can scan the student mark, and to scan we can tell the user to input the student marks. So you say printf input the students marks, range between 0 to 100, and we can go to the next line and do a semicolon at the end. So that is the first thing that we do. And what did we say? To scan, we first of all need our variable to store our student mark. So you can say something like int marks, and now these marks, here is where we are going to store the marks that the person will enter. And what did we say we need to do to get the input from the user? We use scanf, and say the first thing that we provide here is the format specifier. So you ask yourself, what is the data type of marks? And marks is actually an int, and we're saying for an int, the format specifier for an int is %d, and then you put comma, and then the very most important thing, you first have to say and marks. Okay, this is how we can now scan for the student marks. And if we wanted to display it to ensure that we have input them, printf, you can say you have input %d marks. So if you have input something like 50 marks, it will say you have input 50 marks, and outside here we say marks. So let's see. So we are going this step by step, and we say 50, and as you can see, it's outputting. You have input 50 marks. You have input 50 marks. That is how we can get the input. If I input something like 70, 89, you can see that you have input 89 marks. You have input 89 marks. So this is not very necessary, but it's just there to show you that indeed we have captured whatever you have input, and that is why we are displaying it here. So the next thing that we were to do was ensure that the mark is in the given range 0 to 100. So what you can do is ensure the max input is in the given range 0 to we say 0 to 100. Yeah. So how we can ensure this? We can do it in a complex way or in a simple way. So to do it in a simple way is just to use an if statement and just test out and provide the range and say if the max input, if the max is greater, or if, let's say the lower bound if it's less than 0. Okay, so we can say that if the mark is less than 0, that is an invalid mark. So you can say if the mark is less than 0, that's an invalid mark. Or, okay, so you can see here we are saying or if the mark is greater than 100. So here we will use our or condition, and our or condition, you normally use the double forward, the double vertical, the vertical symbol, which is normally called the pipe. This is how you represent the or. The and is represented by these two and symbols. The or is represented by this pipe symbol. So here we are saying if the max is less than 0 or max is greater than 100. Okay, if it's less than 0 or it's greater than 100, you can tell the user that you have input illegal marks, or you can just tell them that the mark you input is not in range. So you just say printf the mark you have input, let's even give them the mark that they have input. So if we have input something like 150, you will tell them the mark that you have input 150 is out of range, and go here and say marks. So these marks will be translated in here, and our program won't be able to continue. So you can say in here, so you can see here we are always returning 0. So this is one of the use cases that we can use another return value. So we can say something like return 1, and 1 means that our program has encountered an error, and this error is actually because we have input something that is not in range. So it doesn't have to be just return 1, you can return any number. So this we have just said that if our program returns 1, we know that it's someone that has input invalid marks. So let us see if we run our program. So if I input 40 marks, you can see you have input 40 marks. If I run it again and input now a negative value, maybe negative 43, you can see you have input negative 43. The mark you have input negative 43 is out of range, and you can see that the program ended with exit code 1. When we see an exit code 1, we just know that someone has input something that is incorrect. So we can translate that to our program and say if we get an exit code that is not 0, our program has not executed successfully. And how we can execute it successfully is we can try and enter a valid mark such that we don't enter here, and you'll see that the exit code will always be 0 if I input a valid mark. So if I input something like 50, you'll see that it will always be 0. So program ended with exit code 0. So exit code 0 always means that the program ended successfully. But in this case, since we are getting 1, if we input marks like 150, you'll see that the mark you have input 150 is out of range, and the program has ended with exit code of 1 because we are returning 1. So this is how we can use the different return types. So the other complex way that I was telling you to ensure that the mark is in the given range is that you can actually trap the user here. If the user inputs, what do we call it? If the user inputs a mark that is invalid, you can trap them here in an infinite loop. So you can create a loop here that will loop forever up until they enter a valid mark that is between 0 to 100. So you can introduce an infinite loop here. And okay, this is not necessary, mind you. You don't have to write all these, okay? The most necessary part of this algorithm is just this determining the mark and awarding the distinction. I think we'll look at that in another program too. So all this is just to show you how you can actually do it. And to do this, we can use a while loop. So you can say trap the user in an infinite loop up until they input a valid mark. So what you want to do is that if you input a mark that is invalid, the program won't continue at all, and it won't exit. It will wait for you to always input a mark that is valid. And to create an infinite loop, an infinite while loop, you can say while, okay, while true. So while true or false, we say that in C, true is represented by 1 and false is represented by 0. Okay, so this is something you need to understand. So if here I said while true or while 1, this means that I am creating a loop that will never end. So if I say while 1, this is a loop that will never end. Okay, and we can just come here. So if we detect that the mark is less than 0, or the mark is greater than 100, we can tell the user to input again, So there are many ways to do this. So I can tell them the mark that you've input 150 is out of range. Then tell them to input again. And now this input again, I will trap them inside a loop. Now inside here, I'll tell them while. Okay, so do I write inside? No, I think I can just write it outside. Okay, so while, so we can say while true. So while true, so I will now enclose this if statement inside this infinite while loop. I will enclose this loop inside the infinite while loop. So if the mark is less than 0 or the mark is greater than 100, first tell them that you have input, the mark that you have input on 50 is out of range, so you just input again. And how do we input again? We say scanf. Scanf, where is scanf? You just say scanf. Then the same thing, %d, and then and the same thing that we did here for the first marks. So and marks. So we now scan for the marks. And if the mark is if the mark is actually between 0 and 100, you can actually break from the loop now. So you can actually, if we get that these marks here is greater than or equals to 0 and less than or equals to 100, we can break from the loop. So we can say if max is greater than or equals to 0 and max is less than or equals to 100, what we can do now is break from the loop. So to break from a loop, this is what we normally use. We use the break keyword. So after we scan and then we find that the mark is actually greater than 0 and less than 100, we can break and say that the mark is legal. So we can actually print out something. We say printf your mark is now legal. Your mark is now legal, meaning that is in the given range. So you can say your mark 150% D, and then here max. Your max is now legal. The max you have input is out of range. So this is how you can, but please, you don't have to cram these or what. You don't have to do this when you are determining input, okay? This is just to show you, if you wanted to implement such a thing, this is how you could do it. And the loop will end. So if I now run my program, and input the marks between 0 to 100 and input 100, you can see that it's saying that you have input 100 marks, but I think there was a problem with that, because let me just do it the simpler way. Break. So if the marks, so let me just input again 100, and as you can see, you have input 100 marks. Okay, so now let us test for a mark that is invalid. So let's test for a mark that is actually invalid, and let's input something like -30. So if we input -30, if I say -30, you can see it's telling me that you have input -30 marks, and it's actually telling me that the marks you have input -30 is out of range. Input again. And if I input negative what, 23, it should be still the mark you have input -23 is out of range. Input again. So it will take me on this infinite loop. If I input a mark like 150, the mark you have input 150 is out of range. Input again. If I input 11 or 102, 11 is still out of range. Input again. So it will keep on giving me this loop up until the day that I will input a mark that is actually valid. So a mark that is valid is a mark like 34, and the program will now continue, or it will end. So you can see that the program has exited with exit code 0. So this is how you can trap someone inside here if they input a mark that is invalid. And the part that I deleted, if I can undo, you can see that I deleted this if statement that was saying your mark is now legal. So instead of having another if statement inside here, what you can do is just to have an else. Okay, so if the mark is This means that the mark is illegal because it's either less than 0 or greater than 100. Else it means that the mark is legal. So this means that the mark is legal. So you can say break. And now this is what will break from the while loop. So this is how you can ensure that that the mark that the user has input is actually valid, and this is how you can trap the user to inputting something that is actually now legal. So you can, before breaking, you can also printf and say your mark is now within range. Say thank you or something. You don't have to be polite. So you can say your mark 150 or 50% D is now in range, and say here outside is marks. So this will print out. And as you can see, if I just input a legal mark, you can see it's telling me that it's actually within range. But if I input something that was not within range, if I input 101, you have input 100, and this will give me that loop again, and I will never continue. Okay, I'll never continue from this up until I input a mark that is actually desired. So you can see it's putting me in this loop that I can never get out of. So if I input a mark like 4, that is a valid mark. Your mark 4 is now within range. So that is how you can actually do that. And now the most important part, so you don't have to do this, okay? When writing the program, the only important part is here, int marks, and then scanf %d and marks. This is the only important part when you're inputting or you're scanning for the mark. Just that. Leave all this. This is because I have received such a question quite a lot. If we wanted to maybe ensure that the user has input something correct. So by the time we get here, we know that we already have a mark that is within range. And now here is where we award. And for awarding, we can just say your award is first class with distinction, your award is distinction. So we can just print out. We can just print out pass, we can just print out distinction, we can just print fail. So here for award, so you can just be using print. You can just be printing award first class. So you can say print award first class, something like that. So what you can do now here is now write our marking scheme or our grading scheme here. So we just write it and we say now we have our marks. So we start from 70 to 100. So we say if, and we said if we have many different conditions, we normally use the else if statement. So we say if marks is greater than or equals to 70, because 70 is inclusive, and marks is less than or equals to 100 because 100 is inclusive. We say what do? We print out first class with distinction. So you say your award, you say printf, then you say your award is first class with distinction. Then we can go to the next line and do that and that. So that is our award. And let me just clear this console. I want to okay, I am adding windows. I just want to do what? To yeah, I wanted to do this so that I can remove whatever is at the right here, the code view, the code map. So you can see here is I have tested if max is greater than or equals to 70 and the max is less than or equals to 100. So you print out that your award first class with distinction. Then you do the same thing for the second condition, which is 60 to 69. So you say else if max is greater than or equals to 60 and max is less than or equals to 69. You printf what? Let me sorry about that. So printf and say your award, then your award is first class, and you can go to the next line and close, and next else if max is greater than or equals to what? 50 to 59. 50 to max less than or equal to 59. So it's between 50 to 59. You say printf your award, then your award is distinction. Then go to the next line and do that. And the other one, else if max is greater than or equals to 40 and max is less than or equals to 49. You say you printf your award is what? Pass. And we can go to the next line and close and do that. And then the last one is else if max is greater than or equals to what? 0 and max is less than or equal to 39. So that is the last thing. Printf your award is fail. Go and see the dean. Yeah, so that is how you can do that. And now if I run this program, so the most important part of this program is right here and here, these two. So this is all you need to implement. You don't have to do all these checks and trapping the user. So here is what you just do, nothing else. Okay, this is how you can now give the award to your user. And now if we run our program, we try to input a mark that is invalid. We say that our mark is -32. You have input -32 is out of range. Input again. I input something like 112. The mark 112 is out of range. Input again. But now if I input something like 60, we expect 60 to be first class. Okay, 60 is first class. Yeah, 60 is first class. So we can say 60. So let's see whether it will give us first. So your mark is within range and your award is first class. Okay, and you can see that the program has exited with exit code 0. So this is the most important part here. So you have to use an else if statement to reinforce all these. And if I input a mark like maybe 10, that should be a fail. So your award is fail. Your mark 10 is also within range and you have input 10. And if I input something like, let's try for a B, I think a B is 50, distinction. You have 50 marks, your mark, your award, distinction. And what I was telling you is that, so remember I was telling you that this second part is majorly not important as per se. You can see that I was telling you that you can just write if mark is greater than or equals to 60, greater than or equal to 50, greater than or equals to 70, greater than or equals to 0. So let us see whether actually that works. So what I'll do is I'll actually discard this part for all of them, the and. because you'll see. So let us see whether it will work like that. So let's see. So if I input a mark like 0, okay, if I input a mark like 10, okay, you have input 10 marks, your mark 10 is within range, your award is fail. And what is 10? 10 is actually fail. If I input 50, 50 should be distinction. So let's see whether it will give us a distinction. So 50. So you can see your award is distinction, and it's actually within range. And the same thing, it's if you input 102 is, you cannot, you have to input again. So you input 101, you have to input again. But now if I input 99, this is an A, the first class. So you can see my award is first class with distinction. So that's about it. This can also work perfectly. You don't have to specify the second option, but it's good for clarity. For clarity purposes, you can just give, and to show that you know how to give ranges in C. So the other thing is using a program to add two numbers, blah blah blah. So let me just read for this. It's saying that differentiate. So before writing this program, I think we can just get finished with the programs first, then we differentiate these theory things here. So this program is the next program. Before we do anything else, I hope we have all understood what we are supposed to do for this program by designing the pseudocode and implementing our C program. So I would ask whether there are any questions based on that. So if you have a question, you can just share your question. So this was 1451. So can you all see my screen first? I hope you can all see my screen. You can react like that. That you can awesome yeah as well. So anyone who has a question, you can just unmute or just forward your question at the chat. If you have any question based on maybe what we have discussed there, if there's a concept that you haven't understood perfectly, because this is what maybe you're expected to do in an exam, maybe this is, yeah. So you can just type your question as we continue. So what you need to do using a program, explain the structure of a C program. So we can actually write a program to add two numbers, and I think I actually what did I we actually talked about such a program to add two numbers. I think it was when we were beginning when we were beginning the lecture. I gave an example of how we can have a C program to add two numbers. Actually, it's in the code. I shared a jump file with the meeting. Oh, awesome! That's really cool of you. Okay, so in case of any question, I did not understand use of scanf. Okay, so let us just clarify on scanf, and I have really emphasized this on class, okay, because I know it actually has a problem. So you can see scanf, and I recall writing it. Very much in class, and also with a very huge font. So for scanf, first of all, the scanf is used to get input, and it comes from the standard input output library. So the scanf is what gives us the input. The printf is what gives us the output. They are like siblings. One is a brother, one is a sister. Okay, so scanf, just know for input if you need to get the input, printf if you want to get the output. Okay, so that is their major differences. And now for the scanf syntax. For you to use scanf, first of all, you need to understand what you call format specifiers. You cannot use scanf without understanding different format specifiers. And what we mean by these format specifiers, these are what are used to specify a certain data type. They specify certain data types in C. And the data types in C, we talked about the data types. We have the int, we have the float, we have the double, we have the character. So these are the basic data types. And now here is where the format specifiers come in. So for an int, you know that the format specifier of an int is %d. For float, the format specifier for float is %f. For a double, the format specifier for a double is %f, and for character is %c. And also there is another one for an array of characters. So you say a character array or a string. So a string is normally a character array. And how do we write a character array? It's written like that. So a character array, this is represented as %s. So now these are what we call the format specifiers. So when you're using scanf, the first thing that you need to ask yourself is, what data types are you scanning? What data type are you scanning? If it's a float, you need to use %f. If it's a double, it's also %f. It's a character, it's %c. So for scanf, the first thing that you always do, you specify your data type using a format specifier. If it's a character array or a string, you say it's %s. So if we were to scan for the marks, the first thing that we did was to declare our marks and say that our marks will be an integer because we want to scan for an integer. So we said int marks, and that int marks signifies that our marks is of the data type int. And what format specifier do we use for an int? We use %d, and that is why you can see that by scanf I am using here %d. I'm using %d for my format specifier, and you write comma, and then you write the and keyword, or the and symbol, not keyword, and you specify now the variable name. If we were scanning for something else, like let's say a character, so maybe we had a character gender. Okay, so maybe we wanted to scan for a character gender which has the values either M or F. And you said for you to represent a character, it's normally single quotes. So for a character, we have a character called gender. And for this character gender, we need to scan it. So the first thing that we did, we declared our first thing to do when using scanf. You just make sure that you have somewhere to store whatever you want to scan. That is the first thing that you do. If it's the marks, we declared our marks variables. If it's the gender, we have declared our gender variable. And now if I wanted to scan for the gender, I would say scanf. And then I write the double quotes. And then here now is where I write the format specifier for gender. And the format specifier for gender is %what, %c, because gender is a character. So I say %c. And then after writing my format specifier, outside the double quotes, I write comma and space, and I say and gender. Simple as that. So this is what will be used to scan for a character. If I wanted to scan for a string, so we say the string is a character array. So you say character name. And then you write now this array symbol. This is an array symbol. And now if I wanted to scan for the name, I say scanf. And then since this is a character array, notice the difference. Okay, here I'm using the array, and array is represented by 2 square brackets. So this automatically becomes a what? It becomes a string. So I say %s and then name, and that will scan for the character array. If it was an integer, I say int age, and say scanf, then age, %d and age. And also I made a mistake here. I just wrote name. This will yield in a very huge error. You always have to specify the and first. Always. This is not even a debate or a discussion, and it's actually telling me that anytime that I declare an array, I have to provide the size. So if I say here 50, this means that this name will have 50 characters. If I say 100, it means that the maximum will be 100. You don't have to have you can have it as a maximum of 100 characters, but it doesn't mean that you always have to fill all those 100 characters. If your name is maybe something like George Abashwili, you can actually store it in this name, and no one will have any problems. But the problem would have come if you say character name and then you say 10 and try to store a name like George Kennedy or something, George Kim Mureithi. You can see that this name has so many characters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are 20 characters. So if you try to store this name in this character name, it won't store the entire name. It would store up to where the 10th character is, and ignore everything else. Okay, so that is how you can actually use scanf. And the last one is if it was a double, so double account, double balance. So you say scanf %f and then and balance. So this is how you can use %f. So I hope you have understood. Does double use %f or 1f? Okay, so that 1f is double also uses %f. And to just show you an example, is I can delete all these, or I can just comment it out so that it can remain, because I think I can share this code and just comment it. Double also uses %f, so let me just say return 0 here, so that this code that is down here won't be executed. So what I can do here is say double balance and scanf, then %f, then say and balance, and I can print out something like printf, enter your balance. So I want you to see something, and I want to show you about that 1f that you have said. If I tell the person to enter the balance, I have the balance, and then I scan it, and with oh, this is this 1 or lf? 1, I think it's 1. Okay, but you can actually still use that. So let me just let me also show you another concept that it's really your balance is, then say %f and balance. So if I did this and showed my balance, enter your balance. So if I input my balance as 1,000, my balance is %f and balance. Okay, so do I have to use L, longer float. So this is so if I input 1,000, awesome. So you can see that the balance is it's actually displaying actually well. So this is I had seen it as 1f, so this is LF, so it's supposed to be LF. Okay, so for a double, so you can say, I think it's for long float or something. So you can say LF for double. And now what you can use this one for here is when you're specifying the decimal places. As you can see, if I input my 1,000, is actually saying 1,000.00000 to no end. So it's actually saying 1,000.00000, whatever. So if I needed to specify maybe to one decimal place, I can now use something like 0.1f or %.2f for 2 decimal places, for 3 decimal places, the same thing. So let me just do that. So if I wanted to specify the decimal place, let me just give you a familiar number. If I wanted to write my value for pi and say 3.1423334, you'll see that it has these decimal places. And if I wanted to format those decimal places, before the format specifier, okay, before the format specifier here, I can say 0.2, and that will give us two decimal places. If I wanted to 3 decimal places, I can say 0.3. So if I wanted to 2 decimal places, I can say 0.2. And if I input something that is that has more than 2 decimal places, it will be converted to 3 point, 4 point, blah 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 blah, and this should be converted to just 2 decimal places. As you can see, it's 4.25. The reason why there is this p is because I am not introducing a new line at the end here. Okay, so that is the problem. If I entered 33 point blah 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 2323, you can see that it's being formatted to the 2 decimal places. And now, for just making it clear, to differentiate the double and the float, you can just say then here is LF, and it's not 1, it's L. Okay, for a longer float, because a double is actually the double size of a float. So we said what are the different things that they actually differentiate it. So this is how you can also specify the number of decimal places, and it's the same for a float. Okay, so if it was a float, so for float it's %f. So if it was a float and I needed something like 1 decimal place, I would have said 0.1 f and balance. And if I input my balance as 1 or 2.3233, it should give me just 1 decimal place, and you can see it's just 1 decimal place. So that is how you can actually use that. So I hope everyone has gotten that. And for scanf, I hope you are able to see how we use scanf for different things. So when we say that for a double, we can use LF. So I hope we are together. So the other program is I will answer the other question, this one, using a program, add 2 numbers that explain the structure of a C program. So using a program to add 2 numbers. So we can do what? Do we write another program, or we can just write it still here, that can add 2 numbers. I think we can just write it here, but the structure is just to describe how a C program normally is. Like we always start with the preprocessor directives. We have the main method. We also can say the use of the main method and the different uses of some of these symbols, such as the curly braces. We normally say that these are used to define the scope, and also we can have different functions, and some of these functions are such as the printf functions, such as the scanf functions, and the structure, we can also say how the addition works using the operators. So we have operators and operands. I think we can just write the program so that I can explain everything. So I'm just turning between whether to create a new project or just continue with this. And let me just continue with this. Okay, so using a program to add 2 numbers. Explain the structure of a C program. So to add 2 numbers, explain the structure of a C program. So we use a program to add two numbers. So the first thing that we need to do is to write this program that will add two numbers. And the question to ask yourself is, do you want these two numbers to be input by the user, or do you want these two numbers to just be declared in variables such as int first number is equals to 20, int second number is equals to 50, and all that? So those are the questions that you need to ask yourself. So in this case, what I'll do is I'll just, so what you need to explain is that in a C program you always start with the preprocessor directive, and this preprocessor directive is used to import the necessary libraries. We say that we can have multiple of them. You can say include stdlib. So you can see that there are quite a lot. All these are the different preprocessors that you can actually include, and these are just from the std. There are others from. So if I needed something like stdlib, I just say std lib.h, and then the include. We can include others from math class, include math.h. We can include different I think there's also a string one, hash include. There string one, let's see, string, exactly. So string, we even have the string and the strings. So you can do all these. Okay, include strings dot h. So you can have multiple preprocessor directives, and now these ones, what they'll do is that they will provide you with so many different functionalities. And if I just click on the strings.h, it will take me to the code of the string class. Look at all the this code. This is what can be used to this is the strings class in C. Okay, if I look at the string class, this is the string class itself here, and you can see it also has other different preprocessor directives. So these are the, you don't need to understand what these are. Okay, these are the what the C guys just wrote for you to enable you to use strings in a much more easier way, like comparing two different values, two different strings. So our program is just to add two numbers. So we just say, we can just have it simple, or we can have it for the user to input those two numbers. So you can say input the first number. So you can say printf input first number, and it's good to go to the next line. And so you say int first number. Okay, first number, and then you scan for it. So you say scanf %d, since it's an integer, and then and first number and first number. So then after inputting the first number, you say the second number. So you say printf input second number. So you can say here, and then you say the second number int second number. Then you scan for it. So you say scanf %d, then %second number, and you just close that. So this is what we can use to get the input of our C program. So we have said we have different preprocessor directives, we have the main function that acts as an entry point. We have the round brackets that are used to define the functions. So for any function in C, it's defined by the round brackets. So these are the different structures, okay? The different features of our C program. Something like the opening curly brace, it will be used to signify a certain scope. This is what we call the scope. So the scope of this if statement, it starts from here to here. The scope of this else if starts from here to here. The scope of this main function, it starts from here to here. So this is normally used to define the scope. And what our program does is we have input the first number and the second number, and then we say the total. So you say int total is equals to first number plus second number. This is what will give us the total, and after doing the total we just print it out. So we say printf total is equals to %d, and you can go to the next line and say total. This is how we can now write that program. And to run it, you can see it will tell me to input the first number 554, second number will be 45. So 554 plus 45 is 599. So you can see that the total is 599. So this is our basic C program to actually do that. Okay. So any question on that? So do we have a question on that? If there's no, we can just finish up the theory on that, which it's just the two. So we have created a program that can be able to add any two numbers. Even if you input a number like whatever, it will be able to give you the sum of your two numbers. And the reason why hii code iko huku nyuma, it's not being executed, is because I have used return 0 huku juu. So I want the program to end when it reaches here. So ikifika hapa where the total is %d, you return 0. And what return 0 does, it ensures that the code will not continue. So that is why this code is not being executed, the one that we had written. But if I was to remove this return 0 or comment it out and have it down here as it normally is, all this code will execute, even the code that we had written earlier. So input first number. So you can see our program is still okay. So you can see that the total is blah blah. But then it continues. Input student marks range between 0 to 100. And if I input 122, the same thing. This is now the first program that we had discussed. Okay, the marks that you have input 122 is out of range. Input again. So you have to input again, and if you input another marks that is out of range, we had that loop. If you input a negative mark, the mark is out of range up until you input something legit like 65, and you can see the award is first class. And after awarding us is now when our program ends. So that's about it. That is the reason why this return 0 was working right up there. Okay, so that is one way you can specify a range of how you want your program to be like. So now for, I think, the last thing, I don't think we'll be able to cover the second cut today. The other one was differentiate between a compiler and an interpreter. So what a compiler does, compiler differentiate between a compiler and an interpreter. So first of all, what we need to know is that we have different programming languages. Okay, these different programming languages, we have languages like C, we have languages like Java, have languages like JavaScript, Python. We have so many different languages, C++, C#, okay? And with these different programming languages, they have their different features. A language like C, you'll tend to find it's extremely fast. And a language like Python, it's not that fast. JavaScript is not that fast. Okay? Some of these languages are faster than the others. And the major reason because of that is one of the features is this, compilation and interpretation. So we tend to find that we have compiled languages, okay? Compiled languages. So for the compiled languages, here is where a compiler compiles the program and converts it to machine code. Okay, so a compiler will take this program and convert it into machine code. And some of the compiled languages, some examples of compiled languages, they are a language like C. C is actually compiled. A language like Java. Java is actually compiled language. Another language that is compiled, C# is also a compiled language. A language like C++ is also compiled. And you'll tend to find that compiled languages are actually faster than interpreted languages. Okay, so compiled. So for compiled, a compiler it will compile the program and convert it to machine code that the computer can understand, that the computer can understand. So that is the work of a compiler. And an interpreter, what an interpreter does, it just interprets, as the name just says, interpreted languages. Compiler, an interpreter interprets the language or code, the language or code. So to just give you an overview, some examples of interpreted languages. So some of the examples of these interpreted languages, it's a language like Python or JavaScript. So let us actually look for some other languages. So we can say compiled versus interpreted languages. Let's see whether we can find the compiled language, blah blah blah. So it's a blah blah blah, the interpreted. Yeah, it's actually another thing that I was to tell you is that compiled languages are actually faster than interpreted languages. So you can see that interpreted languages are slower than compiled languages. So these are some of the so you can see deliver slower performance, better performance, blah blah blah, runs slower, runs faster, implementations. So it executes instructions directly. Okay, so it interprets it line by line, interprets the language. So we can say line by line. So and it's implementation execute directly. So executes directly without compilation. Executes directly without compilation. So what I wanted to get was some other programming languages. Have they not listed? Yeah, but some of the, okay, let's see so you can see the compiled languages: COBOL, C, C++, C#, etc. So you can see these are the languages that I had listed here, and Java is one of them because Java has its own compiler that is called Java-C. And interpreted languages, these ones: Python, Basic, JavaScript. So you can see there's Python and there's JavaScript, and it's what we had actually said. So those are some of the differences between the compiled and the interpreted languages. Yeah, sure thing. You'll get the recording of the video. I've made sure I've recorded because you might want to look back later. So yeah, I think we'll do these for cut 1 and also cut 2, but I don't think there is enough time to do for cut 2. So I think for cut 2 we can do it in class, or whatever you would prefer. But I'll actually share this recording with all of you because you actually all did the same cut. So the last thing was, which was the last question? What was it saying? 4 rules when writing identifiers in C. Okay, so identifiers, think of just let me just copy it and say identifiers. Where is my code? Okay, rules for writing identifiers in C. So for identifiers, think of them as variables, okay, or variables. Think of them as the names, okay, so you can say the names given to variables, but not just variables. These are some of the things that you write, and some of the things that you write are the variables, the functions, because you can have multiple functions. The arrays, you can have different structures. So think of them as functions. Where was I writing? Given to variables, functions, arrays, structures. Okay, these are some of the things that you write, the names that you normally give to identify something. It could be a variable, it could be a function, it could be an array, it could be a structure. And now some of the rules. First of all, rule number 1, okay, like you should never use a white space. Okay, don't use white spaces. So if you're writing your word like a variable here, like first number, you write something like first and then space number. You should not use white spaces. Okay, you should not write please don't use white spaces. Even in writing your function, you cannot have a function with a white space. Also, you can see that we have these reserved words. Okay, a word like printf, a word like int, a word like while. Okay, you can see it's actually, I've just introduced a space here at first number, and my entire program is just shouting at me. You can see error, 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 expected use of what, and it's just because I have introduced a white space. And if I do that or return it as it was, you can see that it's okay. Instead you can use underscore to join your names. So you can use underscores to join your names. And another thing that you need to really know is that you should never use reserved keywords to name your identifiers, such as keywords such as printf. So you can't say there's an int called int printf. That is not even legal. So if you try to say int printf, oops, you can see it's already giving me an error. So printf is actually a reserved keyword to print out things. So you can see everywhere I've used printf, it's now giving me an error, because I have said that printf is actually an int. But if I changed it to something else, int printfs, you can see that everything is okay, because printfs, there is no such keyword in C. If I said int while, that is also illegal. Okay, you can see while loop outside of a function. So these are the reserved keywords. So you can never use them, or you say your function is named void while. You cannot do this, and you shouldn't do that. So those are the different things that you should do. So some of these reserved keywords, they are things like int, while, char, double, for. So you can just Google these things. There are so many. So if I was to Google reserved keywords in C, so all these else, break, short, blah blah blah, they are quite a lot. Okay, they are quite a lot, and you're barred from using all those names in maybe naming your variables or naming whatever you want. And also another thing, you are not supposed to start with a digit. You are not supposed to start with a digit. Okay, you are supposed to start with a letter or an underscore. So you cannot write your name like int one number, int first number. int first number. Even if you write it like that, let us see. You write something like int first number. Even if you obey the rules and say you won't write a space, this first is not allowed. Okay, you cannot write your number like this. Okay, expected identifier. So you can see it's actually throwing an error. You can never start with a number or a numerical value. So what you can do is you can start with an actual underscore. That is, no one is barring you to use that. And another thing is case sensitivity. Case sensitivity. So C is a very case sensitive language. Language. Yeah. So if you write something like int and int are very different things. So you can never write something like int, you say int first number. You can see that there is nothing like int in C. If you write something like printf, there's nothing like printf with a capital P. So you say printf and printf are very different things. So you can say something like printf with a capital P. Printf, say hello world. There's nothing like that. Okay. C will never accept your program. You can see it's actually calling me out for it. So you need to observe case sensitivity rules. Observe all case sensitive rules for your identifiers. So these are some of the different forward rules that you should follow when you're writing your identifiers in C. Okay, so yeah, that is about it. And while giving examples, I should just get rid of this. What else have I written wrong? First number. So scanf first number. So let me just run. So input first number. So I think the first thing here was, this was int first number, and here it was printf input first number. Let's say like that and do that. Yeah, so those are some of all the rules that you really need to observe. Okay, you really need to observe all those rules that that C provides for you. So that's about it. And you need to follow the C syntax in all that you're doing. So do we have any question? Do we have any questions based on our program or what we have gone through? As I said, I will make sure that the recording is available so that you can get back at this, and think we'll cover the next cut later, or maybe in class. We'll see how we can do it. Okay, so yeah, you can tell all the other members that that's what we looked into today. And yeah, that's it for the lesson. Thanks for coming, and that is it.